Hello, today I'm going to walk you through Module 2, Nomenclature, naming organic compounds with multiple functional groups. In this lecture, we will practice identifying priority functional groups, name functional groups as substituents, walk through examples involving ketones and amines, and we'll also go through a sample problem to test your understanding using pharmaceutical organic compounds. Just as a quick reminder, organic compounds are defined as all those compounds which contain carbon except for carbon monoxide, carbon dioxide, and all ionic compounds with carbon such as carbonates and cyanides. As we have covered during our curriculum in Chem 112, classification and naming of hydrocarbons depend on their molecular structure such as single, double, or triple bonds between carbon atoms, whether carbon atoms are bonded in a straight or branched chain, or whether they're in ring-like formations which would indicate benzene rings. Let's do a quick review of naming organic compounds. The following rules enable us to name branch-chained hydrocarbons unambiguously if we apply the rules in sequence. 1. Identify the longest carbon chain. Then identify substituents. Number the carbons to have the substituents at the lowest possible numbers. Name each substituent according to its chemical identity and the number of the carbon atom at which it is attached. Separate numbers from one another with commas but no spaces, and separate the numbers from letters with hyphens. Lastly, list all substituents alphabetically by name. Up in the top right corner, we can see a chart with the number of carbons, so 1 through 10, and their corresponding prefix. Below that shows all of the organic compound groups and the corresponding endings. Carbon chains provide the framework of organic compounds, and other atoms or groups of atoms replace one or more of the hydrogen atoms to form different compounds. In this diagram, you can see the function groups down the leftmost column. In the center, you can see what type of compound that functional group is characteristic of, and down the rightmost column is the corresponding ending. You can also see down the one side with the arrow pointing upwards the increasing priority, showing you the priority of the functional groups. As ketones are one of the more difficult organic compound groups to name, we'll run through some practice problems and go through how to name them. We know that the carbonyl group, or a C double bonded to an oxygen, is the characteristic functional group of a ketone. When the carbonyl group is in the middle of the alkyl chain, we know that the substance is a ketone. To name them, we find the longest carbon chain, giving the carbon a number if there are 5 or more, citing the location of the carbonyl group, and changing the name of the carbon chain. Let's start off with an easy one. Alright, please look at the top right-hand corner of your screen. We can see that we have 6 carbons in our chain, named from right to left, so that the double bonded oxygen occurs at carbon 3 instead of carbon 4. Because of this, we know that the name of this organic molecule is 3-hexanone. Now, there are 6 molecules in the bottom right-hand corner of your screen. I would challenge you to pause the video and see if you can do these on your own, as they are more complicated. Alright, now that you've tried them on your own, did you get them all right? Let's see. For the first one, we have propanone, because we have a 3-carbon chain. We have acetophenone for the second one. For the third one, we have benzophenone. For the fourth one, we have 2-pentanone. For the fifth one, we have 3-methyl 2-butanone. And for the last one, we have 3-hexanone, which is the one we named above. Next, let's go through amines. Amines are named using the IUPAC system of naming, where amino is used as a prefix or to indicate the NH2 as a substituent, as opposed to the common way that we are used to naming amines with ending the name of the compound with amine. So let's go through the topmost molecule first. We can see that we have 6 carbons. We have named them left to right so that our NH2 ends up on the 3rd carbon. We can see that this is now named 3-aminohexane because it's an alkane and only has single bonds. Next, let's move on to this lower diagram. So we need 1 parent chain and 2 side chains. And because we have the side chains coming off of the nitrogen, we denote them with NN, as in NN-dimethyl 1-aminomethane. Alright, let's move on to a sample problem. A new nurse in a hospital needs to find a drug in the medicine storage unit, but unfortunately, somebody was careless and handled the medication containers with wet hands, smudging 3 of the labels off. However, the nurse has found that the diagrams of each of the compounds is located on the back of the containers. She needs to find which of the following structures is N,4-hydroxyphenylacetamide or paracetamol, which is a common painkiller. Our job is to name each of these following compounds to determine which one is paracetamol. Alright, let's start with this molecule. As we can see, we have 3 chlorine atoms right on the edge of our molecule, which are attached to 1 central carbon atom. The carbon atom is attached to the 3 chlorine atoms using only single bonds, indicating that this is an alkane. Because there are more than 1 chlorine atom, we need to use the prefix tri to indicate 3. And because of this, we know that the name of this compound is trichloromethane. Trichloromethane is not the medication that we're looking for, so we need to keep going and name the other 2 structures. Alright, let's look at this next one. We can see that we have a carboxyl group, an acetyl group, and an oxygen right in the center that could indicate an ether, but because of the priority of this carboxyl group, we know it's just going to give us the name oxy. We have a benzene ring, which indicates that we have benzoic acid, so now we need to figure out what this side chain is called off the side of the benzoic acid. And so, because this side chain comes off of the benzene ring at carbon 2, it is 2-acetyl-oxybenzoic acid. This is also not the medication that we're looking for. Alright, out of the 3, we're left with 1, but we still need to make sure that this is the medication that we're looking for. So, we have the NH, which indicates an amide. We have our acetyl group coming off of the amide. We have our benzene ring, and we have a hydroxyl group. And because of this, we know that whatever we have is going to end up as an amide. So I would challenge you to pause the video and try and name this molecule. Alright, now that you've had a chance to try and name this molecule, we can see that the name is N,4-hydroxyphenylacetamide, which makes sense because we have this long side chain including the benzene ring and the hydroxyl group. The hydroxyl group is coming off of the 4th carbon of the benzene ring, and we have the acetyl group right in front of our amide.